Section 3.7. Section 3.7 is all about optimization. Optimization will be an AP topic. It will be something that we will see. It's somewhat abstract, but it's very much an application of all of these extrema that we've been finding. What do we use these extrema to do? We're going to try to apply them to situations and find places that either minimize or maximize quantities, whatever you're specified, based on whatever these given conditions are. So there's optimization. And every time we do an optimization problem, we're going to end up needing two equations. So first equation is the primary one. Okay, that's the one you're asked to maximize or minimize. And the secondary one, a lot of times you're going to have multiple variables given to you in the problem. That secondary equation is going to help you get down to a single variable rather than multiple variables in the problem. So first one, find two positive numbers whose sum is 36 and whose product is a maximum. Sum is 36 and whose product is a maximum. Okay, so let's start this off the right way. So I need a primary equation. What are we trying to do? It looks like we're trying to maximize product. So I'm going to use the letter P for product. So my primary equation, I'm going to have product in there. I'm looking for two positive numbers whose sum is 36. So my secondary equation, what do I have? Well, it looks like I'm probably going to say x plus y, if I call those my two numbers, is equal to 36. So what's the purpose? Well, now the black equation, the primary one, we want the product of those two numbers. So we're going to say those two numbers multiplied together would be my x and my y. Secondary equation, we've got two variables. We're going to try to isolate them. So I'm going to take my secondary equation, y equals 36 minus x. Let's take that 36 minus x, and let's use that to make this primary equation a little bit easier for us to deal with. Now, our job is to maximize this product based on this condition. Now, there's a lot of ways we could do this. Think about how you would go about finding a maximum, how you know about finding a maximum. Well, one way you could do it would be to graph that thing and find its highest value. Another way to do it would be to find the derivative, set up your intervals, use your first derivative test out those intervals and see what we have. I'm going to think all the way back to my days in algebra for a second, or in advanced algebra pre-calculus. This is 36x minus x squared. What does that look like as a graph? That looks like a parabola that would be opening down, which means if I can find what its probable single critical number is, I'm going to have found its maximum based on what I know. So let's do a quick derivative. P prime. What have I got? I've got, oops, sorry, this thing should have a 36x in it. So I've got 36 minus 2x. If I take 36 minus 2x and set it equal to 0 to find my critical number of this derivative, I'm going to find out that x is equal to 18, and based on what I know about a parabola, I know that this maximum is going to occur at the point 18. I just have to go find the y value. So let's take this 18 back up here, and we're going to find out the y coordinate that goes with it is 36 minus 18, or also 18. We're going to have this situation will be maximized if x equals 18 and y equals 18. So what do we actually have? We're going to end up having a max at the point x equals 18, y equals 18. And we just supported it. There's your first optimization problem. So, second one, coordinates of the point on f of x equals x squared that is closest to the point 0, 3. Let's make a little sketch of this. F of x equals x squared. Graph we've seen many times before. 0, 3 is in this vicinity someplace. I need to find the point on that graph that's closest. Well, I'm going to guess there's going to be two of them. I'm going to guess there's going to be two of those distances that are going to be about the same. I just need to come up with what the coordinates of this x, y would be in order to find that. I want this distance in here to be as small as possible. So there's a little hint for what we're going to try to do. So I think that we want closest, which means we're looking for something about a primary equation. We're looking for a minimum distance. So my primary is going to be distance, and we want it to be a minimum. My secondary is already given to me. It's right here. Y is equal to x squared. There's your secondary equation. So let's think about what your distance formula would look like. Well, distance formula, square root, quantity. One of our points that we have involved is this red dot that I created at 0, 3. So let's take those values and let's plug it in. So I think I'm looking at x minus that x coordinate in that equation would be a 0 being squared, plus y minus that y coordinate in there would be a 3 quantity squared. We'll clean this up a little bit so it looks like my distance would be the square root of x squared plus the quantity y minus 3 squared. That's what I'm looking to minimize. So some things that we could do this time. Again, we're going to try to read our variables together so it looks like secondary equation y equals x squared. Let's take an x squared and throw it in place of that y. Now, a couple things I could do. If I had to do this by hand, if I was doing it by hand, I would take that thing and I would find the derivative, I would set up our intervals and all that fun stuff. Well, let's use technology to our advantage. So what we really now have is the equation, the square root of x squared plus the quantity x squared minus 3 quantity squared, and we're looking for its minimum. So let's go to my calculator. Let's plug that in, let's graph it, and let's see what we can find for a minimum. So I'm on my Inspire. So let's go to a new document, and I'm going to do a graphs page. So on my graphs page, let's punch this thing in. So what were we doing? We were doing, let's see, I'm going to go in my templates button. Let's use the square root. And so in my square root, whoops, where did it go? Templates page, square, whoops, I got to get my, sorry, I got to open my graph up. Square root, and in that square root, I wanted x squared plus the quantity x squared minus 3, and we want to square that quantity. So if we take that thing and we graph it, let's see what we get. So we'll graph it. What do we have? And I'm going to move this over. Whoops. Let's undo that. Let's take this equation and let's move it out of the way a little bit. So what do you see? I see a graph. It looks like it has two minimums, which makes sense because we thought there was going to be two of them. We looked at our other picture right off the bat. So I think I need to go and analyze my graph. So menu, analyze my graph. I'm looking for a minimum. I think I'm going to start looking here, and I'm going to finish looking there. I'm going to have a minimum at 1.58, and actually let's move this cursor over the top of that thing, and let's hit the plus button a couple times. So it looks like I'll have a minimum at 1.581 for the x-coordinate, and actually what we should do is we should mouse over this and maybe get an extra coordinate or two. So there would be the coordinates of my minimum value. It looks like since I graphed the distance, so my x-coordinate that I'd be looking for would be my 1.581. So my x-coordinate would be the 1.581, and then the minimum distance would be the 1.6583. Whoops, sorry that thing's in the way. So let's go back and let's answer our question. 1.581. So this thing's got a minimum. We looked at the graph, and this thing has a min at 1.581, and the y-coordinate, or the d-coordinate, because we graphed the relationship between x and d, the d-coordinate is 1.6583. 1.658. So there's my function. Now, is this the answer to my question? Well, I'm supposed to find the coordinates of this point. Well, this is my x-coordinate that I wanted, but remember, I graphed d. So this is the d that I found because my calculator was graphing x versus d. So I found the x-coordinate. Now I go find the y-coordinate. Take this x-coordinate, and let's go back to the secondary equation. Let's take this x-coordinate right here, 1.581. Let's plug it in there and square it. So the coordinates of my minimum would be 1.581, and whatever 1.581 squared would be. I'm going to let you punch that in your calculator and figure that out for yourself to come up with that value. Now, if we go back and we look at our graph, remember how we said a little while ago that there was going to be two potential places that this would happen? If I go back to my calculator and I say, all right, well, what's going on? It looks like there's two minimums. Well, I'm pretty sure that this other minimum over here on the left side of that graph that we're looking at would be at negative 1.581. In fact, I'm quite sure of it. So technically, I could throw in a plus or minus right here because there's technically two places that we can use to answer this question. So there's your optimization, little application of finding maxes and mins for your functions.